I'm here talking with Pete Savagian, Engineering Director of General Motors Electrification Architecture and Electric Motor Release Center. Pete has also managed product development and advanced engineering for GM's hybrid systems. Thanks for joining me today, Pete.
Oh, happy to be here.
GM definitely has some impressive technology in their cars and some new features coming out this year. You now have 4 driving modes in the Chevy Volt. Can you tell me a little bit more about this, especially the new hold mode?
Well, I'll talk about the hold mode. We've had in the car since we launched it a thing called mountain mode, and that's a mode where at some point, if you knew that you were going to go into altitude, instead of preferentially discharging the battery first, we'd immediately go into a charge-sustaining situation, and that is we would bring the engine on and make sure that for the highest grades in North America that we would have unreduced performance. So if you could get to the whole mountain mode selection before you got to that range and you knew you were climbing, if you got there early enough, you'd have full performance at all times. The car could always climb. We were most concerned about losing drive quality in the case where we were going up the highest ranges and the driver first depleted the battery to the point of charge sustaining. And we thought we could give a lot more enjoyable ride. And after all, when people climb mountains, they kind of know that they're going to do that. So that's why we put mountain mode in. Hold is a very similar type of feature, but allows the driver from the onset of the day to start out with the engine on. For instance, if you had a commute and the Chevy Volt is rated at 38 miles of EV performance, so that's full performance EV driving on the battery alone before the engine comes on. But a nice thing that happens when the engine comes on, especially certain times of the year in certain parts of the country, is you get extra heat. You get the waste heat from the engine. And if a person's commute was, say, 42 miles, they drive 38 miles, for instance, with not the best heat, just some heat, and then the engine would come on. So this hold button allows for preferentially the driver to control when the engine was on and bring on the engine immediately, get the heat in the car, and then the engine can go off again. And so on that 42-mile trip could be done with more comfort, still would use the same amount of gas, but rather have the engine on for the first 4 miles than the last 4 miles where it did less good.
Well, I find the Volt technology to be very interesting, especially from the point of view you're using a 1.4-liter engine, which is relatively economical. But unlike a lot of the other hybrids, the parallel hybrids that your competition has, you're using it as a range extender. What were the advantages of building a range extender rather than a parallel hybrid from your point of view?
Well, the Volt is what we call an EREV, an extended range electric vehicle, EREV, which means that unlike what the industry more generically calls a plug-in hybrid, typically a plug-in hybrid is a vehicle where its performance electrically is not as good as its performance with the engine on. We chose to make the Volt an EREV, where the performance electrically is just as good as when the engine's on, because we knew that this was the strategy by which we could displace the most fuel. And so that is to say that when you get in your car and you drive, you get those 38 miles of EV driving, whether you drive fast, slow, accelerate hard, or not. If you go into the other architectures that are plug-in hybrids, while you may have, say, 12 miles of all EV range, according to the test schedule, in the reality, if you go over 65 miles an hour, and I can say I did that this morning, or if you accelerate faster than maybe 50% throttle, and I also did that this morning, even though my commute was 8 miles, I would have still had the engine on. And so you put all this nice fuel-saving electric drive technology in the car, but because of the way it's architected, you're not really saving as much fuel as you could if you made a PHEV. If you made an EREV, like the Volt, an extended range electric vehicle, we've arranged it so we've got full performance under all driving conditions electrically. And so on that same commute, the engine would never come on, did never come on. So that's the reason. We wanted to maximize the amount of electrification or the amount of electric energy displacing gasoline energy. We wanted to maximize that, but still offer a vehicle that had really no special constraints like a battery electric vehicle, which you have to plug in or you're going to lose your range. And, of course, the Volt, you can run that on gasoline all day long and have virtually unlimited range as a result of it. So we wanted a no-compromise vehicle, but maximize the fuel displaced, and we think that formula leads you to an extended range electric vehicle, and that's why we put it in the Volt.
Well, Well, it's very understandable that you want something that the consumer is comfortable with and that they enjoy driving and have a pleasurable experience with the ownership of it. But I know that these things are never easy to achieve for the automobile companies. Can you tell me what some of the engineering issues were that you had to overcome in order to optimize the powertrain for an EREV?
Well, there are several. I would say that one of the hallmarks of the Chevy Volt is quiet and smooth driving experience. And that's a result of General Motors' experience making all of its other vehicles. A very disciplined approach to understanding the keys to driver comfort and things that you wouldn't even normally recognize that you're perceiving while you're driving. For instance, high-frequency vibrations or certain low-frequency sounds are very fatiguing and ultimately annoying. And often you can't put your finger on why you don't really like driving a car, but there's something happening orally or haptically to you in that car that you don't like. And so we spend a great deal of time understanding what makes a car that people perceive as smooth and quiet. And so we've invested a great deal, and the Volt presents that challenge since it's got full performance electrically, and there are very unique electric sounds that need to be abated, as well as it drives with the engine on and elements of the electric system active. So you've got this combination of background noises and vibrations that need to be effectively mitigated in the car over the full range of driving conditions, cold and warm and so on. And so these are some of the real challenges that we faced and applied, we think, good solutions to.
Well, I have to say that, in my opinion, you've been very successful at overcoming those challenges. I've driven a Volt on a number of occasions on test drives and have never failed to be impressed by its performance and its comfort. One of the aspects I'm also impressed by is I like the keyless entry and the keyless start feature that you've got. I've been impressed with that feature ever since seeing it a number of years ago when it was introduced at an SAE convergence session. But in addition to the keyless technology, can you tell me what some of the other advanced electronics are that you've incorporated into the Volt?
Well, the Volt's got a navigation system and control system that we've now enabled with apps for your smartphone or your tablets so that you can keep track of your car, for instance, when it's on charge, and you can understand its state of charge remotely. For instance, when I leave work, which, according to the clock should be 5 o'clock, it often isn't, but I usually know within 15 or 20 minutes when I'm going to leave. And so I can go to my app on my Chevy Volt and I can turn on the heat or the air conditioning while it's still on charge so that when I get in the car, it's climate conditioned right there. We've also got some new apps coming out that interact with the navigation system that indicate where the nearest public charging stations are and whether they're currently occupied. And so that will help if someone's looking for, if they're in town and they're interested in charging up. And often places of business or public chargers offer free or discounted electric charge. It's a real nice benefit for the folks. And so these applications help people make good choices on where they can find them and take advantage.
Pete, I want to thank you for joining me today. It was interesting to learn more about the unique qualities of the Chevrolet Volt. I appreciate your time and wish you and General Motors much continued success.